you'd be fine. Now, what I want to do today is take the stuff we talked about yesterday and apply it to why we're really doing this, the important situation. And here's what it is. Here's how you can put this in context. When we went back to chapter 5, all we're really doing right now is we're extending one of the big tricks we had in chapter 5 to bigger polynomials. Okay, so in chapter 5, when we had stuff like this, I'm going to give you the hardest one I can think of. Okay, so if I want to solve for x there, don't jump in. Take a second and think about it. What do you do to solve for x there?
Subtract 4.
Okay, so you're going to isolate it. Good. Good, because I can point to a single x, I can always isolate it, right? Now, what are the steps I would go through in order to solve for x?
Subtract 4.
That's supposed to be. Oh, it's not. I don't know what it is. Subtract 4, then what? Divide by 2, then what? Square root both sides, then what? Add 3. Add 3, right? Okay, and 4 steps later, I would have my answer, right? Okay, so then we want to. Okay, we're going to do that stuff right now. What are the steps we went through and we did that? So if we add 4, subtract 4, I get 2 times the quantity x minus 3 squared equals 16. Divide by 2. X minus 3 squared equals 8. And then here's the part that where we've got to do a little extension, because we haven't been able to do this yet for the bigger polynomials, right? We haven't been taking cube roots and fourth roots and things like that. But we can. There's no reason that we can't do that stuff. So if I square root both sides, I get x minus 3 equals what?
2.82.
Okay, well I'm getting, square root of 8, which I could simplify if I want to. But you're missing something important. When I square root both sides, what do I have to include? Plus or minus. Okay, now that is something we have to be aware of, because that happens sometimes and sometimes it doesn't. How do you know when you need to put a plus or minus there and when you don't if I'm taking roots of both sides to solve an equation? In this case it was a square root, but it might now, today we're starting to do new stuff. It might be a cube root, it might be a fourth root, it might be a fifth root. Who knows? How do you know when that plus or minus goes there? Very simple. If the power that you're undoing is even, meaning you're taking an even root, a square root, which is a second root, fourth root, a sixth root, a hundredth root, then you put a plus or minus there. If you're taking an odd root of both sides, you don't need to. It's only for even roots. Say it again?
So if that was a 3, just
We wouldn't put it there. Wouldn't need to. It'd be simpler if it were odd. Okay? And so then my answer ends up being, if I add 3 to both sides, I just get 3 plus or minus square root of 8. Okay? There's my answer. No biggie. Okay? So let's maybe look at this. That's bad. What if we had, I'll make a better one. Okay, solve this. What if we had x cubed equals negative 64? Now, we would have had to do this in chapter 6. We would have added 64 to the other side and then factored it as the sum of cubes. Real pain. We don't want to have to do that. Okay. Instead, we can just isolate the x.
So cube equals negative.
Say it again.
It doesn't look like a 6.
Oh, okay. I'll fix that.
Mean about it.
There's our 6. Okay. So now I could cube root both sides, right? To undo a 3, I'm going to cube root.
You look like smudge in the circle. You
Okay, so what is the cube root? Now, can I take a cube root of a negative number? Yeah, I can. I just can't take an even root. I can take an odd root, just can't take an even root. Okay? So,
want to be 16?
Negative 4.
negative 4. There you go. Do I have to put a plus or minus? No, I don't. Okay.
It's fun.
So it makes it easy. Now, there's a couple little things you got to remember, but all you got to, the thing you got to be careful of, they're related. When you're taking roots of both sides, you always remember that I got to put the plus or minus if I'm taking an even root, and I can't take an even root of a negative number. How many times have we said that? Right? We got two notice. We can't divide by 0. We can't take an even root of a negative number. Usually that has meant square root for us, but now it could mean 4th root, 6th root, whatever, any even root. Okay. How about, let's try another one.
You can compile every vector like that.
How about one like this? So x to the 4/3 equals 256. Let me write that down. Okay, so what did we do here? Now, when we solved this last problem, when we had x cubed equals negative 64, I cube rooted both sides, but remember from yesterday, all that really means is I took both sides to the 1/3 power. Because remember from yesterday, we said that if I take the nth root of a, that's the same thing as a to the 1/n power, right?
So this one would just be 1.33.
Okay, so now I took x cubed to the 1/3 power. Why? What's important about those numbers?
Because 3 is the third.
Okay, 3 and a third are both reciprocals of each other, and when I take a power to a power, I multiply the exponents. So 3 times 1/3 gives me 1. X to the 1 is just x, right? So when I cube root, that's really what I'm doing. So now what am I going to do up here?
3/1.
Aha!
Reciprocal it.
Yeah, if I want to solve this one, I'm just going to take both sides to the reciprocal of 4/3 or the 3/4 power. Okay? So on the left side, what do I get?
X.
X. Good. I just get X. On the right side, I get a number, 256 to the 3/4. Now I could put that in my calculator, but I could actually do that one, maybe, in my head. Because I could break it into two parts. 256, if I'm taking it to the 3/4 power, remember that the 1/4 power is just a 4th root. So what's a 4th root of 256? What number times itself times itself times itself is 256? If I made a short list,
16.
2 to the 4th is 8, 3 to the 4th is 81, 4 to the 4th is 216. Or 256, sorry. 256, right? So so this is just 4. The 4th root of 256 is 4, and then I cube it, right? That's really all that means, a 4th root cubed. So then 4 cubed would be 64. So on this side, I would have 64. Now the question is, one more thing. Do I need, I took both sides to a radical power, same thing as a root. Do I need my plus or minus there?
No, it's not an even number.
I
Or technically is it?
I do. I do because the top was even. In other words, when I took this power,
Oh, okay.
it's an even root. Okay? I took an even root of both sides because the denominator was even. Right? That's like a square root. If I took a square root, the denominator would be 2. If I took a 4th root, the denominator would be 3, right? If I took a cube root, the denominator would be 3, and then we'd be okay. But that's a 4 on the bottom. If that's even, then I need to have that plus or minus there. Okay? Make sense? So there's a few rules there. And by the way, you can look at these rules. If you really want to see them in the book, it's fine. They're in the book in chapter 7, 7.1 and 7.2. If you want to see the little green boxes where it gives you the rules and look at a couple of examples, you're welcome to. But I almost don't think you'll need to when you jump into the assignment. Okay, now, what about this one? Let's try this guy. So let me rewrite that. Maybe we get x minus 30 to the 2/5 equals negative 169. Is that going to work? Okay, so if how would I solve for this? How do I get rid of that 2/5 power? Okay, take it to the 5/2 power. Okay, so then I would get, if I take both sides to the 5/2, I get 5/2 on that side, right? And that gives me x minus 30 equals negative 169 to the 5/2. Is that okay to do? Is that an odd or an even root I'm taking? Even root, because look, it's a square root on the bottom, right?
Or minus.
Right, and I've got a minus sign in there. That doesn't match. I can't take an even root of a negative number, can I? And think what this really means. A 5/2 power means a second root or a square root to the 5th power, right? But that square root part disqualifies it. Can't work. Can't take an even root. The root is the bottom part, right? Remember the little picture I drew here a second ago? If we have a to the nth root of a is a to the 1 over n. Now, what is this? What if I have the nth root of a to the m? Where does the n go? If I write that as a fractional exponent, where does the n go? The n has to go on the bottom, because whatever the index of the radical is, the number that tells you what kind of root it is, that always goes on the bottom. The m is just a regular exponent, right? That goes on the top, the numerator. So it's the bottom that determines what kind of root it is. That's what determines what number sits on the radical. So this would have been a second root or a square root. So no go, no real answers. Can't take an even root of a negative number.
999.
Okay, 999, exactly. Okay. All right, which brings us down to this guy.
Wrong.
Okay, that one that's bonus. I tried to make it as hard as I could, but it's not that bad. Okay, what are the steps in order? What are the steps in order I would go through to isolate x
Add
here?
19.
Okay, add 19. Good, that takes care of
Divide by 7.
divide by 7.
Square root.
No, hang on.
Fourth root.
Ah.
Crap, I don't know
What's
why
going on with that one?
I said the wrong thing.
Now, what am I gonna do there?
By 4.
Ah, okay.
Just 4.
I'm gonna take it to the reciprocal power. Yeah. Okay. So I could, on this one, I could add 19, divide by 7, take both sides to the 4th. Then what?
And then add 7.
Add 7. It's getting hard.
Divide by 5.
Divide by 5. We got it, right? Okay, so now there's a lot of steps there. That takes us into the other part of the discussion. So we talked about some problems, and we'll come back to this one. But we looked at a bunch of problems where we were able to take radicals of both sides, take roots of both sides. Now what if we want to do the opposite? What if we're starting off with radicals in the equation? What about something like that? Okay. So the square root of 3 minus x equals x minus 1. Let's do that one. Okay, what do you suppose I should do with this? Now that's the same thing as saying 3 minus x to the 1/2, right? So how am I going to undo? Now the problem with this is, if you look at this thing, what makes this so difficult is I've got x's inside that radical and x's outside the radical. If I want to solve this in the way I've solved all the equations all year, I got to have that look like a polynomial. I can't have that square root in there. So how would I undo it? Square both sides, right?
Yep.
So if I square both sides then,
It's true.
okay, if I square both sides, that's going to get rid of the radical. But you got to be a little careful with this. Here's where something else happens that can cause problems. This is how you solve it, but when I square both sides, I might be introducing solutions that actually aren't solutions, fake solutions or extraneous solutions. So when I'm done with the problem, whenever I take both sides to a power, I have to, to get rid of the radicals. When I'm all done, I got to take my answers and go back to the original equation and see which, if any of them, actually do work. Maybe they all will, maybe none of them will, maybe only some of them will. Okay? So what do I get on the left side if I square it? 3 minus x. Okay, on the right side I get x minus 1 squared. So that's going to give me x squared minus 2x plus 1. Now what do I do? I just FOILed it out. There you go. So now what do I do to solve that? That looks pretty familiar. That looks like a just plain old chapter 5 problem.
Add x and subtract 3.
Good. Okay, set it equal to 0. So we'll add x and subtract 3, and that's going to give me x squared minus 2x plus x is going to be just minus x. 1 minus 3 is negative 2. It's all equal to 0. Right? Okay, now we'd have the option. We'd have the option of the quadratic formula. That would work. Can we do this one easier? Are there magic numbers that work?
Yeah.
Yeah, factors. What are they? Okay, x minus 2, x plus 1. So my solutions are either x equals 2 or x equals negative 1. Okay, so let's go back up to the original problem then and see which, if any, of those work. Okay, so I got to get rid of these guys. So before I squared it, I got to go back to the original problem. Let's try, we had 2 and negative 1, right? Okay, let's try x equals 2. If x equals 2, that's going to give me, what, the square root of 3 minus 2 equals 2 minus 1. Is that true? Yeah. Don't I just get 1? Square root of 1 is 1. 1 equals 1. Check. That works. Okay, so that one works. So let's try the other one. What about negative 1? If I plug negative 1 in there, I'm going to get the square root of 3 minus negative 1 equals negative 1 minus 1. Is that true? Doesn't work.
It's not equal.
I get 2 equals negative 2, right? And that's not true. So that one was extraneous.
What's extraneous about?
Extraneous means superfluous.
That means it's fake.
It means it's serious.
What's that? Yeah, right. It means extraneous means that it's unnecessary, that it doesn't work or it's non-functioning or unnecessary. So in math, it's a word we use a lot.
I know. Okay.
Yeah, that's so it's right. So that's a big math word.
Dookie Hauser? Kid Dookie Hauser was doctor. I got it. Yeah. Love that show.
Shane, why don't you come up here? Yeah, you get front row seat. That's good. That's good stuff.
Good deal.
Okay, so now, we got that one knocked out. How about this one? What are we going to do with this guy? Okay, but it's a cube root, so what would I do this time?
Something different.
Cube both sides, right? Okay. So let's copy that one. So if I cube both sides, I'm going to get just 7x minus 13 on this side. Agreed? Undoes the radical. On the other side, I'm going to cube that out. That's just going to give me x cubed minus 3x squared plus 3x minus 1. Okay, if you cube it all out. So then, what do I do with that? Okay, subtract 7x, add 13. So that's going to give me x cubed minus 3x squared minus 4x plus 12. And then that whole thing would just be equal to 0, right? How would I
Factor by cube root. Factor by grouping.
by grouping? Good. I can't cube root because I have a whole bunch of x's here. I can't point to a single one, but I can factor by grouping. So I could take this group plus that group, right? And that's going to give me, if I take out a greatest common factor, I get, what, x squared, and what's my leftover? Okay. And then plus, I got to have the same leftover over there, so what's going to be, what do I take out? Minus 4? Okay. And that whole thing equals 0. So then I could take my x minus 3 from each group, and I would get x minus 3 times x squared plus negative 4, right, equals 0. And if I'm trying to solve this, now I'll just set them equal to 0 and get my answers. So I would get either x equals 3 or x squared minus 4 equals 0 when x squared equals 4. What are the solutions to that? X equals 2 or negative 2. So I have to try all those. Plus or minus 2 or 3 in my original equation. Well, let's just try them one at a time. Let's try 3. If I put 3 in, I'm going to get the cube root of 3 times 7 is 21 minus 13 is 8. Equals 3 minus 1. Is the cube root of 8 2? No, the cube root of 8. Yes, 2. That works. Cube root of 8. 2 cubed is 8, right?
Yeah.
So that one works. So that one's checked. Okay, let's try. See what happens if we try positive 2. Okay, if we try positive 2, we get the cube root of, what, 14 minus 1 is negative 1 equals, I said 2, right? Oh, positive 1, sorry. Cube root of 1 equals 2 minus 1, is that right? What's the cube root of 1?
1.
1. 2 minus 1?
1.
Check, it works. So positive 2 is a check. What about negative 2? Last one. If I do negative 2, oops, hold on. If I put a negative 2 in there, I get the cube root of negative negative 14 minus 13, right?
27.
So negative 27 equals negative 2 minus 1. What's the cube root of negative 27? Well, negative 3, right? Negative 3 times negative 3 is positive 9 times negative 3, negative 27. So negative 3 equals negative 3. Check, they all work. So we got all 3 of those solutions work for us. Okay? Make sense?
Yep.
Okay? All right, so okay, so if we went back to this problem that we were working on before then, tell me what would we do? We got started. So I'm gonna, yeah, you got a good start on it. Add 19, good. Okay, good. Oops.
And then, what power was that?
Good. So 5x minus 7 equals, wow, 34, that's going to be big. 34, Okay. This is going to be a huge number. So then I would divide by 7, right? This would be a calculator kind of a problem. So then we would just take both sides. Say it again. Yeah, when we cube this, we're going to get some big stuff. So if we were using a calculator to do this then, which is probably good practice, I can just do this whole thing right in my calculator. Okay. Okay, so then I would have 34/7, right? So I'll take the quantity 34 divided by 7, that fraction. To get rid of the 1/4, you said we'll take both sides of the 4th power, right? Okay. So, to the 4th. Okay. And then that gets rid of this guy, right? That gets rid of, then what?
Add 7.
Add 7. Okay, just like you said before. So we'll plus 7.
Divide by 5.
And then divide all that by 5. Good. And that's our answer. Something really big. 112.71, blah, blah, blah. Now, I could check that, though, couldn't I? I could just plug that back in up here for x and see if it worked. Okay? It would, if I did. This one, I just take my word for it. It would work. Okay? All right.